All right, welcome back to school, everybody. I hope you had a good winter break and Happy New Year. And we're off to a new quarter, new beginnings. We're gonna do great, right? Okay. Well, anyway, I'm excited to be back, and I'm excited to have you guys as students again. A lot of you, I think, had my class before, and it's good to see you guys again. And now we are doing stats 102B. So I hope. Anyway, I'm excited for the class. I think. Are these going nuts? Just that one? Should I just turn off the? Or are they all breaking? How do I turn this off? Oh man. Okay. All right. I'll have to. I'll mess with this on another day. Just look at the. Is it all three of them? The one on the right is good? Okay. All right. You know what? We'll shut down the system and then we'll see what happens. Okay. Doesn't work. Power down and restart your computer, right? Okay. So select a source from above, then a display below. Okay. We want this, and I want that. Well, all right. Now I have nothing. Well, okay. All right. Well, I'll just talk. Okay. This is if you're watching the video, you can't see, but I'm showing a picture. I'm showing the textbook. This is a textbook we're going to use. I'm pretty excited. I think this textbook is pretty great. My only complaint is that it does the code in MATLAB rather than R, but other than that, it covers a lot of stuff. We're going to cover a few things outside of the scope of the textbook, and I'll provide some reading for that. But I think it will serve as a good basis to get started. The textbook is called A First Course in Machine Learning, and I know machine learning is this phrase that gets thrown around a lot as if it were something desirable to learn, and I think it very much is. And I know the title of our course is Computation and Optimization for Statistics. And the truth is that while they're not exactly the same, they're very, very similar. And so machine learning is just it's a kind of this fancy way of saying, to kind of encompass this idea that we can create models or learn models or learn how our data is coming, where our data is coming from, without having to have a lot of outside textual knowledge, okay? In that we can use kind of just these strict rules that we can give to, quote, machines or other things to learn these models. And so the book starts off with linear regression, linear modeling, as a basic machine learning idea, and it qualifies. And I think you guys are all familiar with linear regression. And we will start there also, kind of following along with the book. We'll start there as a way to frame the ideas, or a lot of the principles and ideas that go into modern machine learning concepts. Okay. I know last quarter, or in the other 102A classes, I pretty much spent the whole time on the computer typing things into R and whatnot. This class is a little bit more mathematical in that I will be doing a lot more stuff, I think, with the kind of the digital whiteboard. Okay, so perhaps pen and paper may be better suited for for most of the days, and of course we will use R and implement a lot of these ideas that way as well. But just a heads up, there's a lot more math in this class than in some of the other classes. Okay, I'll contact tech support and just tell them all of the screens are flickering. But I'm not sure what else I can do. Perhaps, yeah, I don't know, and I'm sorry. I hope you guys can still learn. Okay, so we'll get started here. I posted the syllabus, and it took me a long time to post the syllabus, and it's still a little bit incomplete in that I haven't finalized the exact schedule of each of our weeks. Okay, but I will hold office hours after class on Mondays. Okay, in my regular old office, and the grading we'll have 50% homework, 5 assignments, 10% each. None of them will be dropped. We'll have a midterm and a final exam. Okay, and then we'll do 10% class attendance and up to 3% extra credit for Piazza participation. Oh, this says 6, but it's 5. I'll fix that, okay? I've changed the a little bit on the late policy for homework, okay? And it's gonna be, most of my assignments I'll try to make due Friday at 6 p.m. And if you'll get same 10-minute grace period. If it's later than that, 5-point penalty, and it will just it'll be 5 points every hour from there. Okay. However, I want you guys to sleep and get rest as well. Sleep is important for your well-being, and so there will be a reprieve on the 5-minute ticking between basically midnight and 8 a.m. Okay. So that. All right, so the idea being, if you didn't finish, you can go to sleep and you can wake up and start working on it again. I recognize in practice that just means you might stay up late, but I don't want it to be this thing where at 2 in the morning you're stressing about it turning 3 a.m. or something like that. Okay, I don't want to add to that thing. Yeah. Was there a question there? Okay. So anyway, I've outlined it, but basically, you know what? And just make sure you don't forget to turn in your homework. Okay. That's that. Okay. All right. And we're gonna try this out. This is how I want to try to take attendance. Okay. We're gonna use this online poll. So I'm assuming you guys all have your phone or computer with you. Okay. So everybody go to onlinepoll.ucla.edu, and I'm going to create one here, and this will be 102B, I don't know, January 9? Okay, I got to create one. Okay, our optional password, I don't know, what's the word of the day? Peanut, okay. P-E-A-N-U-T, okay, and we will do that. We'll add a question, which is, I am here. Question type will be true or false. So I am here, true. Okay. Onlinepoll.ucla.edu. So we're going to create a poll. I'm creating it right now. You will search for 102B. Unpublished? I don't even know what this means. Okay, so we will. Is it working? Poll was successfully created. Can you guys find it? No. No? Huh? There's no questions? Oh, okay. Here, let's. We'll do this. I have to do this. Yeah. Okay. Now everybody, log in. We're trying this out here. Okay, and I'm hoping this will speed up our attendance taking. So just look for 102B And again, the password is peanut, P-E-A-N-U-T. I don't know, I'm going to have to come up with a list of words. Peanut. Here, let me, I'll put the password up right here. You guys, is it working? All right, we'll get the hang of this, okay? The first time you try anything, it's always a little awkward, right? So, you guys, come on. All right, this is our password, is peanut. Okay, and you'll search for 102B. I'm hoping, is this working? Yeah? Yes? Okay, let me see. You're here. Okay, I am here. We'll log in. Oh, okay, 37. How many people are oh, here's the list. Oh, okay, look at all these people. Okay, well, we won't okay, 55. So I guess we'll do this and then 58. I mean, if you do false, I guess that's fine too. I'll figure it out, okay? I mean, I know you guys are here, okay? Okay, the idea being the password. Just don't like text your friend that's not present the password to log in, so. Yeah.
For future reference, will there be a time limit that we need to?
Yeah, I think what I'm gonna do is we'll like run it for a little bit, and then I'll just say, anybody still not respond, and then if nobody says no, then I'm gonna close the poll. Okay? So.
My phone died.
Okay. Well. So make sure you have some kind of electric device that can that works. All right. That's. I feel like 99% of the time it's not going to be an issue, okay? If that happens, you can come to me at the end of class and say, I'm here or something. Well, I don't know. Actually, I don't want to do that because I don't want, I want it to be you guys get here on time and then we're going to close it, right? Okay. Okay, let's, how do this thing keeps refreshing on me. Okay. All right, so then now I'm going to close the poll. Everybody respond. This is just a test run, okay? But everybody's good? Okay, I'm going to close the poll then. And I think, are you sure you want to close the poll? Yes. Let me just kind of, no, hide results. Okay. Oh, this is what I want. Poll responses, 81. Hey, that's great. That's like everybody. I think 82 are enrolled in the class. So we'll get you, all right? Okay. Well, cool. Okay. All right. Well, I think that's much less painful for me, struggling over everyone's names, and I think it'll be good. Okay. So we'll begin. 102B. All right. So this is optimization and computation. Okay. So again, big picture ideas. Okay. So overall as themes in this course, we wish to create models of our data. Okay. So the idea being, we've gathered data from some kind of source, okay? And we want to know what are the things that go into providing this data, right? What factors go into if you're watching baseball, you know what, and the teams score well or score poorly, or basketball, whatever it might be, and you want to know what are the things that go into the score, okay? And clearly, it's based on like the rules of the game and things like that. But we might be able to create some kind of model and say, teams that have players that can get on base, or teams that have players that are able to do this are likely to score in this range. Okay, so we want to create models of our data, and there's kind of this old quote that all models are wrong, but some are useful, right? And that's kind of the idea that we're getting at. We're never going to figure out the exact process for which our data comes from. However, we might be able to create some kind of overarching idea of a model that will get us at least in the target range that we want, okay? So we wish to create models of our data, and there's different ways to create models of our data, okay? So a few. Okay. One is to minimize a loss function. Okay, loss being the difference between the actual data and what your model would predict. Okay, or there's much more complicated ones. Okay, another one method is to maximize the likelihood. And then we have kind of this a bit of a Bayesian approach, okay? And there's a lot of stuff. So I'm just going to kind of wave my arms and just say a Bayesian approach. We'll just. And we'll explore some of these things. Okay. And so, have you guys taken a Bayesian statistics class? No? Okay. All right. Well, let's see. This is 102 week 1. Week 1, Monday. Oh, I need to do that. Okay. Week 1. Monday. Okay. Well, we'll talk about kind of the framework and the thinking that goes into a Bayesian approach. And this is not going to be a full-fledged Bayesian class, but we'll at least get some of the concepts there. Okay, so today we'll start with this idea of minimizing a loss function. And we're gonna work through, I think, an example that we're already all very familiar with, and that's linear regression, right? Okay. And when you guys covered linear regression, do you guys use matrix notation at all? 100C. In 100C a little bit? Okay, but not everybody. All right. Okay, well, let's talk about linear regression, okay? And we will think of it as a way to minimize a loss function, okay? So today we're going to talk about minimizing And so, of course, in linear regression, you've got some kind of data set that looks like this. Right? We're going to try to fit a line. Okay. And we want to find, what is the best fit line, right? Okay. And when you guys are talking about ordinary least squares regression, OLS regression, whoops, something. What we do is we define our loss function is equal to the sum of squared residuals. Okay, and what we're saying is that the function, the slope and the intercept that minimizes the sum of squared residuals will be the best fitting line. Okay, that's how we've defined ordinary least squares regression, right? So we say the best fitting line in OLS regression is the line with the slope and intercept that minimizes the sum of squared residuals. Okay, and I'm hoping this is very familiar with you guys already. Yeah? So, you know, the residual is kind of the difference between the prediction where our line ends up being and where the actual data is. All right, is that good? Okay, so I'm going to start using the notation that the book uses, so that when you read the book, you will not be totally lost by the way it's presenting things. Okay, and just because, you know, every time you pick up a new book, it takes a little bit of getting used to the the author's notation. All right, so we're going to say that our data, okay, the function, so the best fit line, or basically our model function, it's a function of x given parameters w0 and w1, okay? So this is how we read it. So we say a function of x okay, and then the semicolon means given parameter values w0 and w1. Okay, so that's what we were saying. And because this is a linear model, we're going to say that this function is going to be w0 plus w1 times x. All right, so w0 is our intercept, and w1 is our slope. And our textbook, instead of saying this is y, sets this equal to t. T being our value. Okay, so t is here is our predicted value. Okay. And so here, we're going to now define our loss function, okay? Okay, and the loss function here is a function of our model and the actual data values, right? If I'm losing anybody along the way, stop me and ask for clarification. It's my job, okay? Again, I didn't do my spiel at the beginning, but you guys are the paying customer. I want to keep you guys happy. I want your good student reviews, all of that, right? So please, if anything's wrong, let me know. I'm happy. And thank you for the feedback that you guys provided, or if you took my class last quarter, I'm happy. Thank you for the feedback you guys provided. I'm always trying to learn and get better at this. Okay, so here, we defined our loss function as the sum of squared residuals. Okay, so this is what it looks like. Okay, so we're going to just say the loss for a particular point n. Okay, particular point n is the coordinates between x sub n and the value t sub n. Okay, so the loss for a particular point n, we're going to say is L of n. This is a function between the actual data, which is going to be t sub n at that point, and our model, which is this, f given x, or f of x given, w0 and w1. Right? Does that make sense? The way it's written here? Okay. I know a lot of, I remember when I was in undergrad and I had to read these textbooks and then these formulas would appear and it'd be like, I'm gonna just skip over it and read the next paragraph, right? So I'm hoping that here I can explain how these formulas are structured and what they mean, and that when you see them in the textbook, it will make sense to you. Okay, so this is the loss function, a function of t sub n and our model, right? So this is our data point, data value. This over here is the model. Okay, and the loss here is the difference between our residual squared. We have a question.
So for the model function inside the loss,
Yes.
do you specify x as xn at that point?
Yeah, because this is the loss for one particular point n. Okay, this is the loss for, and then we will just expand this and say the loss overall is we're gonna add these up. Okay.
So do we need to say that f bracket xn?
Oh yeah, that's a very good catch. I apologize. Thank you. See, you guys are okay. Yes, so it's f of x of n. So this is the model, I guess, model at point n. All right, data value here. I'll write data value at n, and this is the model at n. Okay, and this over here is going to be the residual squared, right? So I'll just write this in words now. Residual squared. So what is the residual? The residual is going to be the value t sub n minus what the model predicts, right? So we're going to just take this part and plug that in here. So it's going to be minus w0 plus w1 times x sub n. That's the residual. And we're going to square that. Oh, the book actually just keeps this in the in this form. Sorry. Just for so what I match or what I have will match the book exactly here. They write this. They just throw in the model right there. Okay. Is that good? So this is the loss for a particular point n, and I just want to make sure everybody's good so far. And that when we look at this formula, we don't just go, I don't know what this is saying. I'm going to skip it. Yes, question.
Question. If the loss function is the difference, the square difference of the actual value minus the predicted value, right?
Mm-hmm.
But here it is saying that t is the predicted value.
Yeah.
And f is our model.
Yeah, this is, so maybe I should put a little hat over here or something. In our model, we're trying to say that our data, this is what our data is coming from, and this is the difference between here t sub n would be the actual data value, and yeah, maybe I'll put a little hat here or something to indicate that this is our predictions. Okay. Yeah, I understand. Maybe we don't want to get too sloppy with the notation here. Okay, and then so the loss function overall will be, we're going to just find the loss for everything, okay, and add them up. Oftentimes when we're talking about loss functions, we talk about the kind of the average loss, okay? So I'm going to go ahead and just say kind of the overall, the average loss is just going to be L, and we often just say it's 1 over n, the sum of all of our L sub n's, okay? So this is going to be n minus, or n from 1, n equal to 1 to big N for all of our data points. So this is just our average loss. That makes sense, right? And so for linear regression, this means we're going to just plug in what we have for L. N. So we're going to have 1 over n, the sum of n equal 1 to big N, and our L sub n is the function of our data values, Tn, and the function, our model, x sub n given W0 and W1. Okay. Good, and then we can further expand this if we want, but I don't think we need to. Okay. And we say the parameters that we will select for our model are the ones that minimize the total average loss. Something going on out there? Okay, and so we will say we express that as argmin W0 over W1. So this is find the arguments or the values of arguments W0 and W1. So this is that minimize. And in this case, it's our average loss. So it's going to be find the parameters that minimize this. Okay. And that's ordinary least squares regression. Okay. We could. The book mentions other loss functions. So there is something called median regression. I don't know if you guys have heard of that. And that minimizes the absolute values, okay? And that has different properties. So ordinary least squares regression will run through the mean of x and the mean of y. If you're trying to minimize the absolute values, you end up it's going to run through the median of x and the median of y and things like that. This is kind of the sidebar. We have other loss functions. It might so median regression, or they might call it quantile regression. That minimizes the absolute values of residuals rather than the squared residuals. Okay. And we kind of favor dealing with squares rather than absolute values because the absolute value function has a non-differentiable point, right? It creates a v and you can't take the derivative there, and so when you try to do math, it gets stuck and you get in trouble. And so, when you have the squares, it's like, oh, it's generally easier. But whatever, you can do it this way too. There's no law against it. Okay, good? All right. Oh man, it's already 3:40. All right. This class goes quickly. All right. Okay, so basically I think in 100B you had to do all the derivations for this anyway, right? You showed that this is the thing, so we're going to skip the derivation, the analytic optimization, right? But basically so probably the summary of this, of which I'm going to skip the steps, is you take partial derivatives with respect to w0 and wn. You set those equal to 0. Find those spots, and those will give you your global mins, or your local mins. Okay, so take partial derivatives of loss function with respect to w0 and w1, set the derivatives equal to 0, and to find local mins. And it turns out, because it's quadratic, the local min is the global min. And that's how you get your solutions to what is the best fitting slope and intercept. Okay? And then you solve to get the solution for best slope and intercept. Okay. Is that good? All right. Let's. Okay. So now we can expand this. Okay. So this is just with a slope and an intercept, but in multiple regression, we can expand this further, right? Okay, so I will okay, so we'll have basically more terms. Okay, so not just slope and intercept. So we could have a function of basically x, and so I'll just start off with kind of x1, x2, x3, x4, and then we would have a w0, a w1, w2, w3. Okay, and this we could say, oh man, I regret how many things I've put here. But you have kind of the intercept and the slope for x1 plus the slope for x2 plus so on and so forth, right? And you would have a bunch of values here, okay? And so instead of having to express our terms all written out like this, we can create a W matrix and an X matrix and say we're going to look at the product of our W's and our X's. Okay? So we could say we have a W matrix such that consists of W0, W1, W2, W3, and W4. And then we will have an X matrix, okay? And so maybe I'll just have, X1. Okay. And we'll notice that if I wanted to multiply these together, we'll run into some problems because here I've got 5 W terms and here I only have 4 X terms, right? So if I wanted to do W multiply X transpose times W, we have basically dimension mismatch, right? Here I have 4 X terms and 5 W terms. So what we do in order to accommodate the fact that we have an intercept, which is not a variable, we modify our X. So we keep the same W, but our X now has, we append the value 1 to it. Okay, and then so now we can do X transpose, which will be 1, and then we can multiply it by W. So X transpose W would look like this. And we would end up getting exactly what we had before. We'll put this right here. Okay. And so in this way, this allows us, by using matrix notation to accommodate our X's and our W's, this allows us to kind of compact things and we can, rather than having to say each value is W0 plus W1 plus X1 plus all of this, we can just say, you know, each of our values, you know, maybe our T hats or whatever is going to be X transpose W, okay? So this makes things a little bit more compact and a little bit easier for us to deal with in the future. And so we'll pick up right here on Wednesday, okay? And so we'll put a pause right here. We'll pick up right here. We'll continue our discussion of linear regression from this perspective.